Hello and welcome to the Daily Space for today, June 4th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Before I get started, I want to remind all of you that you can do science while you learn the latest science news in a different window, not this window. Keep this window open. In a different window, click on over to bennu.cosmoquest.org and you can help us map out all the rocks, all the boulders, the occasional craters on the surface of the small asteroid Bennu. The OSIRIS-REx spacecraft needs your help because starting July 10th, it's going to be doing high-resolution follow-up imagery of the most likely places for it to dive down and grab a sample of soil, of pebbles from the surface of this asteroid. Without you, we may not be able to map all the images that have to be mapped. We have 4,500 images, each requiring 15 people to look at them. So click on over now. That's bennu.cosmoquest.org and help us do some science. Okay, so on to today's news stories. In our top news for the day, producing at the same time as talking. In our top news story for the day was a very confusing press release. The press release that I got came from Hubble. But the image that I'm showing you, it's the image on the left, the blue kind of ooky image, that's from the Very Large Telescope here on the ground down in Chile. Scientists have recently used the MUSE spectrograph on the European's Southern Observatory's Very Large Telescope to confirm two separate planets in the process of forming around a star located where that clearly fake star in the center is. And this is the first time we've caught two separate planets in the process of forming that could be directly imaged. And the reason that I put all those caveats on is we've previously found one other system that was in the process of forming multiple planets, but we didn't detect it the same way. So the central star in this system is PDS 70, and it's 370 light years from Earth. It's a young star. It's just 6 million years old. It's slightly smaller and less massive than our own sun. And its innermost planet is all the way out at a distance similar to the distance of Uranus in our own solar system. And it's estimated to be somewhere between 4 to 17 times the mass of Jupiter. Now, the other star, PDS 70c, is newly discovered. It's on the outer edge of a disk gap at a distance similar to Neptune's distance from the Sun. So essentially we're finding Uranus and Neptune in another solar system. It's less massive, weighing somewhere between 1 and 10 times the mass of Jupiter. And these two worlds are orbiting in resonance so that the inner world goes around twice for every one time the outer world goes around its host star. So this is an exciting system that we're going to get to watch orbit its star thanks to direct imaging capabilities. This is kind of awesome. And artists are having way too much fun illustrating this particular system. And I just want to point out that part of the reason that the masses of those planets have so much unknown in them is because these planets are still forming. This is a system that over the course of humanity, if we live past the next few years, we're going to get to watch this solar system form. And that's just kind of awesome. Now, in other news is the most confusing image I think I have ever seen. This came to us from the Johnson Space Flight Center, and It is data from NASA's NICER instrument. This is the Neutron Star Interior Composition Explorer. It's mounted on the International Space Station. And when I first looked at this, I was trying to figure out why there appeared to be filaments connecting pulsars. And what you're seeing here is an ingenious new way that they're finding to map out the sky in X-rays. Now, the goal of their instrument is to study all of the pulsars that are the bright labeled in green objects all across this all-sky image. The filaments that you're seeing are images that are taken, or rather chains of observations that are taken as the instrument scrolls across the sky. So for instance, as it goes from pointing at the Cygnus loop up here over to, actually I'm not seeing any filaments connecting. Let's pick two things that connect clearly. So as the instrument goes from this object right here, it might follow this crazy sweeping pass over to Vela. And the entire time that it's slewing across the sky, it's taking data point after data point after data point along that slew, allowing us to map out the sky in X-rays. Now, as the instrument slews between prominent pulsars and prominent pulsars, it's building up over and over these different paths. And this is starting to detect other X-ray sources in the background. So you can start to see actual signal in all this crazy noise. So the filaments aren't actual structures connecting the pulsars. They are the path of the telescope as it slews across the sky from pulsar to pulsar. And over time, the instrument is going to build up an X-ray map of the background. And this is a kind of cool way to get an all-sky map. Now, this is 22 months of data, so it's going to take a really long time to do this, but it's essentially free data. The telescope has to scroll between sources anyways. And so now, literally no moment of time gets wasted with this particular telescope. So yeah, it's just kind of cool. Anyways, and in more pulsar-related news, the Fermi Gamma Ray Observatory, once upon a time known as GLAST, has taken a look at a millisecond pulsar. This particular pulsar is a field star. It's not located like so many pulsars are in a globular cluster. It has the ever so poetic name of PSR J0952-0607. This particular system consists of an overweight neutron star and a companion star that is just 0.02 solar masses. These two objects are orbiting around each other every 6.42 hours. This is a system where the pulsar has most likely stolen a great deal of material from its companion star. And now it's rotating 707 times per second. It's probably been spun up in the process of consuming that extra matter, and in the process consuming a lot of additional angular momentum. This highly spun up neutron star is not only emitting the radio emissions that we're used to, but it is ever so very faintly also giving off light in the gamma rays. And what's interesting is the peaks in the gamma rays are leading and trailing the peaks in the radio. So why this is happening? We need more data to figure out. We need more theorists to figure this out. But it's still kind of awesome to see that this particular object can be seen in gamma rays. And this will hopefully allow us to figure out more about the physics of these high energy objects. So from two planets forming around a not so distant star to a new way of mapping out the sky in X-rays, to a new way of looking at pulsars in gamma rays. It's kind of an all-star kind of day. And I will now take your questions. While I type those in, I am going to remind all of you that we are a production of the Planetary Science Institute working in collaboration with Youngstown State University. The Daily Space comes to you every Monday through Friday at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. Guido, I still need to know what you're making for dinner right now. We come to you live right here on twitch.tv/CosmoQuestX. If you miss us live, you can always follow up over on the CosmoQuest YouTube channel. We archive all of our shows and make sure you always have a chance to know what is new in space and astronomy. We are brought to you by you. We are ever so very grateful for all of your cheers, your bits, your donations, your subs, your Patreon patronage. If you like what you see and you're not currently either a sub or a Patreon, please consider becoming one. This really allows us to know what our month-to-month budget is going to look like and allows us to figure out how to pay my co-host Annie Wilson a living wage. So let's keep the science going. Now, if you can't help us with a financial contribution, that's okay. We totally get it. We can't support everything we want to support financially either. And there's lots of other ways that you can really help us out. The best way you can help us out is just telling other people. Inflict CosmoQuest on others. And the other great way you can help us is to do science. Help us out by mapping out, well, Bennu for the OSIRIS-REx team. So I am now going to scroll through the chat and see what questions you have for me to answer. Oh, I'm hearing it's too warm for hype. It's actually cool here today. Thank you, Trekker Kev. Thank you so very much. We thank you for your donations with cute dogs because we can. So thank you for your contributions. Yeah, we are in the high teens Celsius, high 60s Fahrenheit today. It's kind of amazing. I don't know how this happened. I'm not going to complain. I'm going to celebrate and be confused. Scrolling for questions. Ooh, so Binary Ablaze, Annie Wilson is saying that there's going to be a Bennu marking support stream following Daily Space. So stay on this channel. Don't go anywhere. I'm going to be turning this over to our own Binary Ablaze to, well, help you mark rocks, and we can do this together. I'm going to be actually working on the software, and so I'll hang out in chat. Woot, planet formation. I love that. Hello, Bad Panda. I love watching you guys say hello to each other. For those of you who haven't seen it, over on Discord, on the random channel, Bad Panda Bear got one of the Apollo lander Lego sets already and has assembled it, and it is amazing. Go check out all the cuteness. Veronica Cure asks, could the bright spots with no tag be newly discovered neutron stars? So let me pull up the image that you're talking about. So if you look, there are a variety of bright spots all throughout this that aren't necessarily bright just because there were a bunch of things intersect. They could be either supernova remnants or additional pulsars, and it's going to be awesome to find out exactly what they are. All those things are likely. Okay, so let me see what other questions. That was a kind of short answer. Yeah, it does look like figure skating patterns, Paranor. I agree. So Henny's Warver was asking, could all that spinning make the neutron star last dance? No. The gravity on these things is so strong that the spinning really doesn't have an effect on their radius. It's yeah, the gravity on these things would squish you down to being like millimeters tall if you were on the surface. Maybe not even a millimeter tall if you tried to stand on the surface. It's a lot of gravity. Scrolling. Thank you again, Trekker Kev, for the bits. Guido is asking airplane food. Paranor is asking Guido airplane food today. I still don't know what you're having for dinner. Jay Sierra asks, could you go into a bit of depth on why stellar mass loss is still an unsolved problem and what is being done to figure that out? What will we need to do going forward? So stellar mass loss comes in two different forms. Cannibalism, which is what happened in the binary star system we were talking about. That one's actually fairly well understood. You put two gravitational masses too close together, and the one with stronger gravity is going to suck the atmosphere off of the one with less gravity through a process that is called Roche lobe overflow, just because the guy who figured it out was called Roche. And it's a gravitational lobe that's teardrop filled, that when you fill it and you keep pulling, it overflows and streams onto the other star. Now, the other kind of mass loss, which is what I think you're talking about, is where you have stars at a variety of different stages in their evolution that are giving off their atmosphere to space. Our own sun regularly spews matter in the form of coronal mass ejections, and there's a steady stellar wind blowing pretty much all of the time, which is cool, but we don't know exactly how much mass is coming off in all directions, and how much mass comes off is actually the determining factor in whether or not the Earth will someday get consumed when the sun bloats up to become a red giant star. Now, a star like our sun doesn't have that much mass loss going on, but a massive red giant star, something like a Mira variable, has a very diffuse outer atmosphere. It's extremely extended. It's not well held onto, and it's gradually puffing off. With stars like V838 Mon, I think I got that number correct, pulses of light moving away from the star actually illuminate all the mass the star has lost that surrounds the star. Planetary nebula, in some cases, are extraordinarily complex, and it's thought that some of that complexity comes from how the mass was lost from the star. One of the justifications for building the Hubble Space Telescope was to actually understand planetary nebula and exactly how they get the crazy structures they get. We're not there yet. We're still working on it. Sometimes one telescope is not enough. What's being done to understand it is more and more observations across more and more wavelengths, and hoping for more objects like V838 Mon that have these amazing light echoes that allow us to study the structure of the mass around a star. It's also going to take a lot of computational models, and that takes better computers. So a combination of improving computers, improving models, and improving telescopes is going to be how we solve this problem. It's not a very satisfying answer, but it's actually kind of how we come to understand everything in astronomy. We just keep looking, and we just keep building better computers. And as all the technology advances, so does our understanding. Looking to see what else is in here. Hanny went on to write, could that swirly image actually cover the whole sky someday? Hopefully. It is from an instrument that's attached to the International Space Station, which means it has access to the entire sky. I don't know if they're going to change the tracking path of the telescope as it goes from one object to another enough to do that efficiently, but there's the potential. It all depends on how they choose to slew the telescope. I'm not seeing any more questions. So That's all I've got for today. Directly following this stream, directly, Annie, I'm trusting it's directly. Directly following this stream, our own Annie Wilson, Binary Ablaze, is going to take over, and she is going to be doing a support stream for mapping the asteroid Bennu. I will be in the chat as soon as I'm done fixing myself some lunch. Still don't know what you're eating, Guido. There's bits. There's bits. There you go. Eddie once again tried to catch them, failed spectacularly. My lunch is going to be a bagel with turkey. He said pasta salad. Excellent. I approve. Much better than my turkey sandwich, probably. So thank you for being here. Once again, we are a production of the Planetary Science Institute, working in collaboration with Youngstown State University. We are brought to you by you. Thank you so much for your bits, for your subs, for your patronage over on patreon.com/CosmoQuestX. If you really want to help us out, spread the word. Spread the word that people can do science. Spread the word that we have this show. Help us grow our audience of people who are learning and doing science, because we are here to put science in your brains. Now, I don't need to raid anyone, but I am going to roll the credits. And stay tuned after the credits for Annie taking over and mapping Bennu, wherever you are in the world. Have a fabulous morning, evening, afternoon, and I'll see you on the other side. Bye-bye.